So now in this video we have a current source using a PNP bipolar junction transistor. And one thing to keep in mind, this is actually a current source. We have the collector that's going to provide the current to a load, or we could short to ground the collector, so it's not a short circuit really, but we can short the collector to ground, and we'll get 10 milliamps of current. And with the load we'll get 10 milliamps of current as long as we got enough supply voltage to power everything. So, in any case, I'm using a 2N3906. If you look at the front, then the left is the emitter, middle is the base, right is the collector, but since we put the flat side to the left, now the top pin is the emitter, middle pin is the base, right pin is the collector. And so, we set a voltage at the base. We're going to use a Zener diode to do that. 5.6 volt Zener diode. The cathode, the black band right there, is to the positive supply. The anode, the side without a band right there, is to the base of the transistor. And then we got this 10K resistor headed to ground right there so that it will pass current through the Zener diode right there. And it takes about 5.6 volts in order for the Zener diode to start conducting, but then it conducts freely, and therefore we need a resistance to ground right there. The thing is though, like I said, it doesn't really conduct until you get to about 5.6 volts, and then it conducts about freely. So that means that it is going to build up 5.6 volts across it. And if you look at the component closely, it actually says 5V6. They take the V for voltage and put it where the decimal point is going to be, because you probably won't be able to see the decimal point on a component this small right there. But you can see the V when you use a loop to, or a magnifier to look at it. Your bare eye might see it too. But in any case, we need whatever voltage the load needs, and then 5 volts across this 500 resistor. So as I said before, this is a 5.6 volt Zener diode. Whatever voltage we have here, so if this was 9.6 volts, then we would have, it drops 5.6, we'd have 4 volts right there. That's the way that it would work. And then this is going to be 0.6 volts higher than that. So it'll be 4.6 volts there. 9.6 subtract 4.6 volts there would be 5 volts across the resistor. But doesn't matter what voltage the supply voltage is, as long as everything can handle the power. We're going to maintain 5.6 volts less at the base. And then this is headed towards the positive supply right there. It's going to be 0.6 volts higher right there, making a 5 volt difference. Hopefully that makes sense. But yeah, I used a 500 ohm resistor. It's actually 510 and 510 up there. It doesn't really matter. That's close enough. I don't have any 500 ohm resistors, and 510 is really common. And we don't need 100% accurate 10 milliamps of current. Anywhere close to that is just fine. So now, I got the multimeter here. We're going to set it to measure current, and we have to be careful at this point, because you don't want to accidentally measure a voltage when you have the meter set to measure current. It doesn't limit current, it lets current flow through it freely. So if you put too much current through it, you can blow a fuse. So I got the power supply. Right now it is set to 5 volts, and I did limit current to the power supply. So we're not going to damage the meter. That's 20 milliamps of current maximum that this will provide right there. But we got the 9 volts. And I think things will go a lot quicker if I attach my little breadboard jumpers there that I just crimped with a pair of pliers, alligator clips to the other side. So our voltages are, well, we're measuring current, that's right. So we're going current to the ground rail right there. And then I got the red probe right here. I'm going to do the same thing right there. And so yeah, we don't have to see the probes anymore. They're the multimeter probes. We are just going to short circuit this right now. Is that a bad spot in the board? So yeah, I got to make sure I put it where the collector is. So there we go. About 9.65, and semiconductors start conducting a little bit better as they warm up. So I think it's going to go up a little bit, but it'll level off at some point. So this is not part of the circuit yet. I got the anode of the LED to the collector of the transistor. So we're just going around the LED, and wasn't a conductive path at all until now. So there you can see, we changed the load significantly. There was no voltage drop at all. Now there's a couple volt drop, and the exact same amount of current, 9.68. So I'm going to add another LED in series. Got to move this jumper down, And now we got a lower current. So we can probably solve that by raising the supply voltage by about a volt right there. And the more load we got, the higher voltage we can get. At this point, I don't think we have to stop at 13 volts, but that's what I wrote on the sheet. So maybe I did that for one LED or something. So I'm going to add a couple more in series right there. Just plop them in, LEDs. So we got up to 4 LEDs in series, but right now there's 2. So it's 9.68. And I went up 1 volt, so probably now I got to go up 2 volts to make up that difference. So it's very important you realize you need enough supply voltage in order to maintain that amount of current. And then again, we'll go up a couple more volts right there. And 9.7, things are warming up, so it'll probably conduct slightly better. That's where you run the risk of thermal runaway. We don't have a risk of that right now. We have the current plenty limited at some point. But when things warm up, semiconductors especially, they tend to conduct better. Not all of them, some of them conduct worse as they heat up. But it's very common for them to conduct better. So always be aware of that. Make sure you got stuff, resistive stuff along the way to make sure to take up some of that power. But there you can see, again, it's almost the exact same current that it was before. So I'm at 14. That might be a little high. So let's see, 13. Let's go back to a 13 volts just in case. So we're going to get rid of one of the LEDs. I can just bypass it, but I'll pluck it off the board as well. So the main thing was, first, without the LEDs, we looked at 9 volts, and it was basically the same amount of current we got there. Maybe just a tiny bit different. So I'm going to go up to the collector right now. And there you can see, it's basically the same amount of current right there. And whether we got that or all these LEDs, as long as we have enough supply voltage. When we started with 9 volts, we couldn't light all these LEDs. We had a lower current. Something to be aware of. So you want to make sure the now we really don't have to worry. The LED popped out, but there we go. We're not connected to the board at all anymore, and we got the probes. They're just floating. You'd have to put them across a voltage source now to force current through this or anything else that has voltage. But get it off of measuring current as soon as possible. Some meters have a power button. Still, get it off of measuring current. Voltage is a good setting. And then hit the power button. I don't have a power button on this one. I have an off setting, so I don't have to worry about that. Be aware of that. And then also, I tend to mention this, that most of my videos I use 5 volts, no more than 20 milliamps of current. And so, many times when I get to the power supply, I assume that's what it is set at. So, whenever I change the voltage and increase the current there, when I'm all done, and I know I'm done completely, I try to remember to always get it back to 5 volts, 20 milliamps of current max. So if I try to turn on a circuit that needs more than this, and it's not working for some reason, sooner or later I check that, I'm like, oh yeah, I didn't raise it yet. But I don't have to worry about damaging anything with too low a voltage and current. But higher voltage and higher current than what a circuit can handle, could blow it. So that's just one little recommendation that I have that you do to protect stuff. But in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I posted on the screen and check out the links down below. They all help out a lot. I'll see you on the next video.